Math is clean, math's easy when you're doing math with Miss Lee.
Welcome to a lesson on section 3.8, higher derivatives. In this lesson, you'll learn about notation for higher derivatives and implicit differentiation for higher derivatives. You've already worked a little with the second derivative, so you've seen the f double prime notation. Likewise, the third derivative would be f triple prime. Once you get into the fourth derivative and higher, we stop using the tally marks and just place a number in parentheses. For example, the fourth derivative of f, instead of using 4 apostrophes, would have a superscript 4 enclosed in parentheses. In Leibniz notation, the first derivative dy dx is modified with matching numbers between the d and the y on the top and after the x on the bottom to indicate a higher derivative. In our first example, we'll find the fifth derivative for the function x to the fourth minus x squared plus x plus 1. This is a fourth degree polynomial function, and we're being asked to take the derivative 5 times. You may already suspect what's going to happen. Every time I take the derivative, the degree of the function is going to decrease by 1. The first derivative will be a third degree polynomial. The second derivative will be second degree. Following the pattern down, the third derivative will be linear, the fourth derivative constant. That means the fifth derivative will be 0. In our second example, we have the implicitly defined equation x squared plus y squared equals 16, and we need to find y double prime the second derivative and y triple prime the third derivative. Applying implicit differentiation once, I get 2x plus 2y times y prime equals 0. At this point, I have an option of isolating y prime and then taking its derivative. Alternatively, I can just apply implicit differentiation one more time. And this is what I'll get. I had to use the product rule to take the derivative of 2y times y prime. Solving this equation for the second derivative gives us negative y plus xy prime over y squared. I can't leave the y prime the way it is in there. My answer should be given only in terms of x and y. So I do need to isolate y prime in the first blue equation, and then substitute that expression in place of y prime to finish solving for the second derivative. As an aside, you should notice that if we had chosen to isolate y prime in the first place, and then used the quotient rule with u equal to negative x and v equal to y, we would have ended up with y double prime equals negative y plus xy prime over y squared by that method also. I still need to find the third derivative. If I'm going to differentiate y double prime, I think it'll be easier if I simplify a little first. However, if you chose to use implicit differentiation with our second blue line above, I would suggest replacing those y primes with negative x over y first. Using the quotient rule on the second derivative, and substituting negative x over y for those y primes, we get this. This concludes our lesson on section 3.8, higher derivatives.